In this video, we'll discuss a couple of remaining parameter properties that we haven't covered yet, including the obtain from and symbology properties, and we will introduce the progress bars, both the default and step progressors. We did type, direction, multi-value, default or schema, environment, and filter, and we still haven't done obtain from. And obtain from is a property that you can set that will allow you to derive information from one of the other parameters the user inputs. The user inputs shapefile for parameter number 0. You can use the projection from that shapefile that they've entered to set the projection for parameter number 1. Or the example that I have on this slide is you can use obtain from to get field names from an input feature class or a table. So what you do is you set up your parameters. So you have to have one from which you can get fields. But if there's a parameter from which you can get fields, when you enter a field data type in another parameter, if you go down here and look at the parameter they obtain from, you'll have a pull down that'll have an option of the things from which you can get the field names automatic. So what it'll do is it'll automatically populate those field names for you. It'll look in and find what fields it has. If I were to say have two input features, an input table and an input feature class, I would have both of those choices down here, and I could pick from whichever one I wanted to allow it to derive the fields from there. So this is a nice way if you need to have a user select a field on which to operate. Say, you have a data set that has latitude and longitude information, and you need to pick which field. If there's more than one latitude and longitude column, you need to pick which field it is. You can set it up to derive the fields that way. And so that way you're ensured that the user doesn't pick something that doesn't exist, right? A field that doesn't exist. What's another way that you could create this? Remember, I call this a combo box. Is this just a text box with a list of things pull down menu? Any other? Remember last time we talked about filters? Yeah. So you could use a filter to create this, but the difference between using a filter and this is that this is going to be dynamic. So if you use a filter, you'd have to hard code field names beforehand. So if you use this, then it can update based on whatever input the user selects for the first parameter. So there are only certain data types that the obtain from property applies to. This is so this is the list of data types in the left column to which it applies. So if you're, in other words, if you select your data type over here, when you select that, that will automatically update whatever is available. The default is to be obtained from nothing, right? It's not default to check to set itself to input file. You have to set it that way. But once you set up a data type, an input data type, if it's one of these, and if there's another field, if there's another parameter that has a data type that's one of these, then it will automatically give you the choice of selecting that parameter. Like in this case, the other data type, that the field data type can select from a table data type, and so it gave me the choice of doing that. So obtain from is only available for these particular data types. And I think the one that I've seen people using the most commonly is the field, grabbing those fields. Next, we'll discuss how to use the symbology parameter property. You have to pre-prepare a set of symbology layer file, a .lyr file. You know how you can export to layer. So you create a data set, or you have a data set, you create the symbology that you want for your output. You export that from ArcMap as a .lyr, a layer file, and then you point the symbology property to that layer file. So it would be something that you put in your data directory so that your script can still know where that is and point to it. In other words, you'd want to have a relative path to the layer file. And then once if you have like derived output or required output, you know how it can be added to the map automatically after the process runs. Well, if it's got a layer file that it's pointing to with this symbology, then when it's brought up to the map, it will have the symbology that the layer file had. So, for example, if you've got a layer file that has these little information points, they have little eyes inside, they're blue with little eyes inside, and you set the symbology to this information.lyr, you bring it up and you set it the symbology property down in here to wherever that layer file is, then your output that you bring up to the map is going to have the symbology that the layer file has. Okay, so the layer file's feature type needs to match the feature type of the output. So in this example, the layer file is point features and the output is point features as well. Yeah. So kind of cool, a little bit more limited. They just don't give you the control to do the kinds of things you can do in ArcMap with, right click, change colors, change sizes, and so forth. In fact, if you we didn't have time to look at QGIS, but when you look at QGIS, which is an open source sort of desktop mapping, kind of equivalent to ArcMap in the open source world, it allows you with Python to do a lot more tight control of the symbology. However, programming it is really complicated. So I think I'm guessing that the reason that they didn't expose that part of controlling the symbology in the ArcPy library is just because it just gets complicated very quickly. So, they're on the KISS method on that one. So another way to do the setting symbology, again, this requires a training layer, but there is a tool called Apply Symbology from Layer, which allows you to, if you have data that you want to use the symbology of one layer to train the symbology of another layer, you can do that. So that ends the list of, we've been through all of these guys, the type, direction, multi-value, default or schema, environment, filtered, obtained from, symbology. All of them, you know how to use all of them. Another little piece of using script tools is that you can inform the user of progress as it's working along. Let the user know what things you've gotten through. If you run the script tool just as it is, it already gives you this bar with these little dots that are oscillating back and forth. As you're waiting, it goes. By default, it says the name of the script tool up in the top left corner, and then up here it just says executing and then the name of the script tool. So there are two ways you can modify the standard progress message that you see. You can either use what they call the default progressor or the SetProgresser. And this involves just calling some ArcPy functions It's arcpy.setProgressor and things like arcpy.setProgressorLabel that are designed specifically for controlling this the look of this thing with for script tools. Okay, so we've never talked about them before because we haven't been using script tools. Jonah?
What's the difference between those two?
Between standard and default?
SetProgresser and SetProgresser label.
Oh, okay. So SetProgresser label is SetProgresser is the command that you have to do if you want to use something other than the standard thing. And the thing that you can do with the default is you can update this little message here. Okay. So once you have, deleted land 197, you can say, or when you're just about to delete it, you can say deleting land 197, for example. If this is assuming I'm inside a loop and I'm probably updating this as I go. So the SetProgressor tells it whether you want a default or a step progressor. See, the first argument is always either default or step. And the second argument is a message. It'll be the first message that shows up here. I didn't take a screenshot of it before it changed to the second message. But that message, whatever you put in here, will pop up right here. In the second argument will pop up there. So with the default progressor, usually you just want to put a message in. There are other arguments that you can use if you're using the step progressor. And so for the default progressor, basically all you have to do is say SetProgresser default, whatever message you want to show initially, and then SetProgresser label every time you want this message here to change. Okay.
So you only have to set the progressor once.
SetProgresser once. And here's so the third bullet is meant to be like a separate example. So this would be in a separate script tool. So the SetProgressor gives you this nice percentage bar. So the percentage bar is useful if and only if you know ahead of time how many things you're going to be looping over, right? Because otherwise you can't figure out how long the bar should be ahead of time. Okay, so if you have, here I've hard-coded it. It doesn't necessarily mean it has to be a hard-coded link, but here I've hard-coded that it starts out at 0, you haven't done anything, and then you have 4 steps, so I put a 4. And then I set up the, I'm setting the label in the second, so, and then I set the progressor position, and this is the thing that makes the bar start filling up. Okay, you just say set progressor position. Since I am calling, this is the first time I've called set progressor position. When it starts out, before you call set progressor position, it starts out at 0. Okay, I've taken a screenshot right here after it's been called once. Why is it at 25%? Because I've called it once and there are 4 steps. Okay, it's a quarter of the way through. So if I call this again immediately, even if there's nothing has been done, it'll still show 50%. It doesn't have any intelligence about whether you've actually done the things that you're claiming to do. You have to just cleverly put it in your code so that it updates as the progress occurs. Okay. So it'd be like, well, I'll show you an example. You put it out, if you have a loop, you put it after you set the progressor position after you perform the steps within the loop. So to summarize, you have a default, you have a step. There are actually 4 methods that are related. I don't ever use a reset progressor, but that would take you back down to 0, and if you were using the step progressor. So the step progressor for the step mode is slightly more complicated. So let's look at an example for that. So you'd set progressor for step mode. It's either default or step for the first argument, and then whatever message label you want to put up on there at the outset, and then the minimum value, which we usually, for most applications, you just want to use 0 there, and the maximum value. So for most application, that's going to be the number of times you're going to go through your loop, right? Or for a simple example, so in this example, I'm going to loop through data, right? I've got, what this script does is it's going to delete data based on what I tell it. So I'm telling it whatever workspace, and then I'm telling it a feature type, which can be either raster or feature class, or maybe I shouldn't call that feature type, file type, I guess, raster or feature class or something else entirely. And then I take a wildcard, which could be a substring. So what this, basically I built this part of the tool out of aggravation of, I was running tools repeatedly and generating these output files, which I then wanted to delete so that I could run the tool again and see that it had actually created the output. So this is so if I say the type is raster, I get a list of, so suppose we just say that my input was a workspace that has rasters, and I get and I say the type is raster, and I don't give any special thing on that. So if the type is raster, I get a list of rasters that have whatever substring I've specified, or if I don't specify any, it'll get all the rasters, and I pass that into data. And then down here, I'm going to loop through the data and delete everything that's in my list. So up here, I've gotten my list of data of things that I'm going to work on ahead of time. And then I go down and I do the looping. So here's where, on line 31, is where the SetProgresser command is called. And I call it as a SetProgresser. I pass in a message, sort of a generic message of what I'm doing. And then I start it at 0, and then I finish it at, what is this guy? Len data. What's that going to come out to be? Yeah, it's the number of items in the list, the length of the list. Okay, so instead of 4, as in my previous slide, I'm not hard coding the number and setting it to whatever the length of the list is. And then I loop through the data, and first thing I do before I do anything is I set my label, progressor label, that says I'm going to be deleting file blah, and then I delete file blah, and I print that I've deleted it, and I set the progressor position. And what is this time.sleep doing here? You know what that does? Anybody? I don't think I've talked about it, but I just thought maybe you'd come across it. There's a time module, and time.sleep for the 3 makes it stall for 3 seconds. Okay, so if you're looking at the step progressor and trying to figure out what it's doing, if it goes too fast, you can't see it. So it just holds it. It holds the process until, so it'll get to line 31, execute line 31, get to line 32, wait for 3 seconds, and then execute line 33. So if you're creating a real application for real sharing, not just for demonstration purposes, you won't want to have time.sleep in there. Even though we all want more time to sleep. Or is it just me? Okay, so yeah, so that's how it works. So I've got that. After I delete it, I set that progressor position. So I surrounded I put the label, I did the operation, and then I set the position to the next, updated it. So that's the step progressor. We talked about obtain from symbology, the default, and the step progressor.